All right, we have solved linear equations, right? And tell me how you recognize a linear equation. Oh, I told you. You're telling me one form you can get the equation into, and that's right. You can get solve for y, and then the coefficient of x will be the slope, and the constant will be the y-intercept. But how do you know when you're just looking at an equation in any form whether or not it's linear? Thank you very much, Isaac. First degree. Now, I think I've said that every class, and I got one person who can answer me. The way that you recognize a linear equation is a first degree equation. The highest exponent is 1. So we have solved linear equations and we have graphed linear equations. And the slope-intercept form that you mentioned, was that Maddie? Yes. No? Yes. The slope-intercept form that you mentioned, Maddie, is a good tool for graphing. It gives us information we need for graphing. So combining those two things, the solving equations and the graphing equations, we're going to use both of those today to solve systems of linear equations. And what a system of linear equations is more than one equation with more than one variable. You could have 2 equations with 2 variables, or you could have 3 equations with 3 variables. They get exponentially more difficult to solve the more equations and variables you have. When you get past 3 equations and 3 variables, if you ever have a need for that in some class that you have, you'll be dealing with matrices. There's a whole class on that. A matrix or matrices deal with systems of equations. But just to deal with 2 equations and 2 variables, we don't need matrices for that. We're looking for the values of x and y that make both of the equations true. So that's our definition of what it means to be solution to an equation. It's what makes the values, what makes the equation true. So for a system, a solution is what makes both equations true. We're only going to deal with 2 equations and 2 variables. The solution set is an ordered pair, x and y, which satisfies both equations. If a system has a solution, we say it's consistent. Consistent just means has a solution. Inconsistent means has no solution. So make sure you understand those 2 words. All right, there are different ways of solving a system. We're going to talk about all 3 ways, but we're really only going to use 2 of them. The first way is by graphing, and show me with an arm, one of your arms, what the graph of a linear equation looks like. Right? Most of you aren't committing. I saw a couple of people who gave me lines with positive slope. A couple people give me lines with negative slope. I didn't see anybody give me a vertical line or a horizontal line, but all of you can make a line with one arm. All right, now make a line with your other arm. This is all the ordered pairs that makes one of the equations true. This is all of the ordered pairs that makes the other equation true. So what can you say if those 2 lines cross in one point? I mean, what you think? Well, mine kind of looked perpendicular. I didn't necessarily mean that. Let me make them not look perpendicular. I'm just talking about the points where the 2 lines cross. What can you say about if this is all the solutions to the first equation and this is all the solutions to the second equation, then what's that one point that's on both lines? It's the solution to both equations. In other words, that's what we're looking for. When you're solving a system by graphing, you just graph one line, you graph the other line, and you look for that one point where the 2 lines cross. Now, could 2 lines cross in 2 points? With 2 straight lines? No, it'd have to, one of them would have to curve back around to hit the other line again. So we can have one solution, that one point where they cross. Show me what else, with your arms, show me what else can happen with 2 lines other than them crossing at one point. They could be, looks like you're saying, Barbara, I got your name right, didn't I? It looks like yours were one was right on top of the other. And that is one possibility. What would that mean about number of solutions if one line was right on top of the other? There's infinitely many solutions because we said there's infinitely many solutions to any one linear equation. That's why we graph them. We can't list all the solutions, so we draw a picture of them. If the two lines really lie on top of each other, then they're the same line. They have the same solutions, and they both have infinitely many solutions because really they're the same equation. So that's the second possibility. One point, all the points, or infinitely many points. What's the other possibility? Show me with your arms. Ooh, what's the word for this? They could be parallel lines, which would mean what about number of solutions? There are no solutions. There are infinitely many solutions that make this equation true. There are infinitely many solutions to this equation, but there are no common solutions to both equations. So I've summarized that in your notes. If there is a solution, we say the system is consistent. And if they only cross in one place, there's only one solution, we say that the system is independent, or the equations are independent of each other. They're different equations. Second thing that can happen is they could be parallel, which means there are no solution. And when there are no solutions, we say the system is inconsistent. And then the third thing that can happen, one line lies right on top of the other, and the system of equations has infinitely many solutions. All the ordered pairs that are on the line, we say the system is consistent and the equations are dependent because really they're the same equation. I've listed that for you, gave it to you in words. Some folks like pictures better than words, so this picture says the same thing. You can see one solution, no solutions, infinitely many solutions. What word do we use when there's no solution at all? No, one of the two words in bold type right at the top of the page. There's no solution. We say the system is inconsistent. If there's at least one solution, we say the system is consistent. If the two equations really are the same line, then we say, what about those equations? Another bold-faced word. If they're really the same line, we say the equations are dependent. And if they're different lines, we say the equations are independent. All right, you can work on those words. When a system is consistent and independent, when they only cross at one point, it can be very difficult to pinpoint that solution, especially if you're not using graph paper and a ruler, or if the solution's not a whole number. Let's say I had two lines that crossed at the point 1/8, 1/3. Do you think I'd ever be able to locate that by graphing on paper? Exactly. I don't think so. So that's why we were going to talk about the graphing method, but we're not really going to use the graphing method in case some of our systems come up with fractional solutions. The two methods that we are going to use are substitution and elimination. So let's go ahead and look at those. To solve a system by substitution, for example, this first example, it has two equations, it has two variables, W and H. The thing is, that first equation only has one variable in it. I can go ahead and tell you what H is. What does H have to be to make that equation true? 8. So I can tell the value of one of the variables without doing any work at all. And if I can find the value of one of the variables, then I can substitute that value into the other equation, 2w plus 5 with 8 substituted in the place of h equals 8. So 2w plus 40 equals 80, and 2w equals 40, and w equals 20. Now, my question for you is this. Did that system have one solution, two solutions, no solutions, or infinitely many solutions? Only one person's willing to commit. There's only one solution. I tried to fool you when I threw that option of two solutions in there. That's one ordered pair, one solution. If you write it as an ordered pair, you could write it as 8, 20. We usually have X's and Y's in our ordered pairs, or if we have something other than X's and Y's, but we don't know what the variables stand for, we just put our ordered pair, the variables in alphabetical order, so H before W. What would we say about that system as far as consistent and inconsistent? Which one? It has one solution, so that's consistent. Consistent is at least one solution. And in addition to saying the system is consistent, what can we say about these two equations in terms of dependent, independent? Two solutions that cross in one point, just have one solution. We say the system is consistent and the equations are independent. Now, actually, on the test, I don't ask you to say consistent, dependent, independent, inconsistent. I just ask you to find the solution if there is one, and then tell me if there's one solution, no solution, or infinitely many solutions. I think those words are easier, and you know what they mean. All right. So that substitution was very quick on this one. On the second example, substitution may not be quite as fast because the difference is in number one of my equations only had one variable. I could just squint and tell you what the variable, the value of that variable had to be. That's not the case in my second example. Both of them have two variables. So how could I get something I could substitute into the other equation? I remember this from somewhere, algebra 2-ish. Tell me what you're thinking. Is that Emily, perhaps? No. Tell me your name. Shelby, gosh darn it. Tell me, Shelby. All right, I may not be able to get a numeric value for X yet, but I can certainly get the X by itself and have some algebraic expression that I can substitute into the other equation. So like Shelby said, I could subtract 2y from both sides. And I don't have a number to put in place of X, but I do have an expression I can put in place of X in the other equation. And by the way, if you draw lines on your paper to keep up with what you're substituting where, that's fine. That's a good idea. Yes, sir. You put 0. Let me see if I can help you figure out the answer to that, Justin. If I put, you mean at the same time, let X be 0 and let Y be 0? Oh, one at a time. If I were graphing, what is it that we find when we're graphing lines? We let X be 0 what are we trying to find? X is 0 for the y-intercept, and y is 0 for the x-intercept. So, Justin, what that would do is help me graph this line. And then I could do the same thing to graph this line, but then I'd be solving by graphing. I would be looking for the 2 points where or the 1 point where the 2 lines crossed. If I'm not trying to solve by graphing, I don't want to do that. All right, but what I can do is substitute that 8 minus 2y in place of this x. Copy down the rest of the equation. And now I have one equation that only has one variable in it. And I know how to solve that. I've been solving those since 8th grade. I think when 8th grade was, I think it was in the 70s. Yeah, I think I made a mistake. How did that 12 get to be negative? Minus y, negative 7y. Oh, 12 minus 24 is negative 12. That's when I subtracted 12 from both sides and divide by 7. I got 12 sevenths. I didn't remember having an example that had a fractional solution yet, but unless somebody sees something goofy I did, y is 12 sevenths. Any questions about that? Miss Cardi, is that okay? You're looking like, what the heck? So tell me what's bugging you. Is this line okay? Is this line okay? Is this line what's bugging you? Oh, that's okay. And so this is okay. I don't believe you, Carly. A negative divided by a negative is a positive. And by the way, I have these instructions on the test, but I want to make sure that you understand why the instructions are there. On the test and in the homework, in algebra, we don't use mixed numbers very much, and we never change a fraction to a decimal unless the directions say round. 12 sevenths is an exact answer. If I divided and got 1.7 something something, that would not be an exact answer. So the test says leave exact answers, fractions as your answer. Don't change it to a decimal and round it. All right. So this is going to have one solution, but I only have half of it. Where do I get the other half? Put the 12 sevenths back in place of y in the other equation. So again, if drawing arrows everywhere helps you, that's fine. You'd have x equals 8 minus 2 times 12 sevenths. And then in my happy bubble, all of you can do that in your head. But if you don't know how to use your fraction button, please wave at me and let me show you. That's so easy with a fraction button. I don't want anybody to miss this on a test because they're not using the fraction button. 32 sevenths, I think. Yep. Anybody going, where the heck? I don't know how to do that on my calculator. All right, so again, this only has one solution, and it's the ordered pair. Make sure you put your x first, regardless of which one you found first. 32 sevenths, comma 12 sevenths. That's been difficult to find by graphing. I don't think I could pinpoint exactly 32/7 on a graph. Any questions? So substitution works really well when one of your equations only has one variable. That was super easy. Or one of the equations has a plain old X or a plain old Y that it's easy to get by itself. Now, we could have solved this first equation for Y, and nothing would be wrong with that. I would just have fractions I had to plug into the other equation by substituting or by solving for X and not getting any fractional expressions. It just made the substitution easier. Any questions?
I do have a question.
Tell
It's
me.
maybe a stupid question.
It's quite all right.
What if there was a variable with your X? So if hypothetically, if it was 6X plus 2Y, say,
Okay,
what would you do then?
okay. That is awesome. It's almost like I paid you to say that so that I could follow up with if none of the variables are plain old X, and when I say plain old, I mean 1X or 1Y, which is what you're describing, then I probably wouldn't use substitution. I would probably use my other method. I could use substitution, but I'd just end up with fractions I had to plug into the other equation. And as long as I have a fraction button on my calculator, that's okay. But I wouldn't choose substitution as my method if all of the variables had coefficients other than 1. So let's talk about that other method, elimination. I want to do this same equation. I want to solve this same system, but show you how we could solve it in a different way. For example, there's something different than what I meant to happen here happened, but I can show, I can show it to you anyway. This is the same system that we just solved by substitution. Elimination is based on the fact that this equation really means X plus 2Y is the same thing as 8. Just like I can add 8 to both sides of an equation, I can add X plus 2Y to both sides of the equation. That's why elimination is legal. But what I didn't realize when I typed this is adding these two together wouldn't really help me. I'd have 4X plus Y equals 20. That's still an equation that has two variables in it. And I can't solve just one equation that has two variables in it. So I didn't mean to have to do this on this example, but I'm going to have to figure out some way, something I can do to one of these equations that would cause one of the variables to eliminate if I added those two equations together. Do you understand that if I added them right now, nothing would eliminate? Can anybody think of anything legal that I can do to either of those two equations to make something eliminate? Multiplying, is that a legal thing to do? Can I multiply both sides of this first equation by 3? Yeah, that's legal. My next question is, do 3X and 3X eliminate? Oh, multiply by -3. You're absolutely right. I'm going to multiply that top equation by -3. Both sides of that equation by -3, it will become -3x minus 6y equals -24. Top equation becomes when I multiply both sides by -3. And that second equation, I'm not going to do anything to it. I'm just going to bring it over. And then What happens when I add those two equations together? Exactly what I wanted to happen. One of the variables eliminates. Negative 3x plus 3x is 0. I have negative 7y equals negative 12. So guess what? We get the same answer when we solve that equation by elimination as we did when we solved it by substitution. I'm just going to say x equals 32/7 from example 2. I don't want to redo those fractions. But if we put that 32/7 in place of this x, no, I'm sorry, if we put the 12/7 in place of that y, we would get the same x value that we got in the previous example. So on the test and on the homework, really, I don't think I say which method to use. I just say solve the system, and you can solve it any way you want to. You could solve it by graphing, but if those two lines don't happen to cross at integer values, I don't think you'll be able to figure it out. If either one of the equations only has one variable, or one of the equations has a variable with coefficient 1, then I'll probably use substitution. But when none of the variables have a coefficient of 1, I'll probably use elimination. I just wanted to do this problem 2 different ways to show you how to use both methods on the same problem. We need to do some more of this, some more by elimination. Really? That's my. There's. Am I missing a page, or is that your next page? That's your next page? Okay. Let's say these problems have really a 5-part process. First, we're going to solve the system. I think we'll use elimination on these 3 examples because there's something specific I'm trying to show you. But after you've solved it, say whether there's no solution, 1 solution, or infinitely many solutions, because that's what I asked you on the test. But then in the homework, say it's either consistent or inconsistent. And if it's consistent, say whether it's dependent or independent. I'll get to this last thing in just a minute. Not yet. All right. First thing I think when I look at, that's my second example 2. I did a lot of typing this summer. First thing I think is, man, I wish I didn't have all those fractions. That, yeah, that looks horrible to me. But I know how to get rid of fractions in an equation. What do? You have any ideas about how to get rid of fractions? Not the reciprocal, but the LCD, the least common denominator. Good, James. I need to multiply both sides by the LCD. I don't have to multiply both equations by the same thing. To clear the fractions out of the first equations, I could just multiply both sides by what? 2. That's why I retyped the equation for you. I don't ever want you to write on your original problem. You need to be able to look at the original problem and see what it was before you started messing with it. But the top equation, you can multiply both sides by 2 to clear out the fractions. The second equation, you'd have to multiply by what? The LCD is 6. So multiply both sides of that second equation by 6. Now, all of my arrows are just showing that I started with this system, it transformed into this system. And next it's gonna transform into a system that doesn't have fractions anymore. If I distribute that 2 through the top equation, it becomes 2x plus y equals 12. Second equation, you can punch 6 times 3/2 on your calculator if you need to. It's 9x. And you can punch 6 times 2/3 on your calculator if you need to. But you should get 4 with a coefficient of y. And the right hand side, you can punch 17/2 times 6. You should get 51. Any questions about what you need to be punching on the calculator to get the second equation that I have? All right. Would this system now be pretty easy to solve by substitution? It would. It'd be easy to get this y by itself. I'd have y equals 12 minus 2x. I could plug 12 minus 2x into the other equation. So substitution would be a way to go. But if I want to stick with elimination, what could I do to one of those equations that would cause something to eliminate? Equation by -4, I'd have a -4y and a +4y. My y's would eliminate. That's awesome. I could also multiply the top equation by -4.5 and cause my x's to eliminate. Which one's easier to multiply by, -4 or -4.5? -4. So that's what I'll do. I'm looking for the easiest way to solve this. And let me grab a different color here so you can see what I'm doing. I'm multiplying the top equation, both sides, by -4. And then I'm going to rewrite the whole system. The first equation becomes -8x minus 4y equals -48. Second equation, I'm not changing it. 9x plus 4y equals 51. So far, I've just been rewriting my system in a way that would set up what I wanted to happen. And I'm finally there. I can finally add those two equations together and my y's will eliminate. I'll have x equals 3. That was kind of nice. -8x plus 9x is 1x. -4y plus 4y is 0. And -48 plus 51 is 3. Have I solved that system? Only halfway. I know half of the solution. I know x equals 3. Now, where do I get the y that goes with it? You could actually plug it into any of these equations that you wanted to.
I just did the 2x.
I would too. I would look for the easiest equation to substitute it into, and it looks like maybe this equation's the easiest one. I could plug it back in here. The fractions wouldn't be horrible. As a matter of fact, even though I would probably do what you did, let me just say into the first equation. It doesn't have to be the first equation. That one's pretty easy to work with. Just subtract 3 from both sides and multiply both sides by 2. And you get y equals 6.
What if you plugged it into 2x plus y? We'll do it that way.
Absolutely. And let me write down one solution. Say something else about your question. There's one solution. It's the ordered pair 3, 6. For those of you who did substitute the 3 into this equation before I multiplied it by -4, did you get the same thing? Yeah, the reason you can plug that 3 into any one of the equations is because ultimately it has to make both equations true. So you can use any one of the equations to find the other value. One thing I haven't said on the previous examples that I should have said, what's the greatest thing about taking a test on solving equations? You can always check your answer when you solve an equation. I'm gonna just make a note, check solution in both equations. It would be a little bit gnarly because I would have to check it into the original. I might have made a mistake by the time I got to this point. You always check your answer with your original equations. So I would have to check, zoom out enough you can see both fingers, but you can't read the writing. I would have to check that 3 plus a half of 6. What's a half of 6? 3. So 3 plus 3 equals 6. It certainly makes the first equation true. The second one would be the little bit uglier one to check. Might need a calculator, but I could punch 3/2 times 3 plus 2/3 times 6 and make sure that it gave me 17/2. And it would, I'm confident in that answer. All right, so we've done what A says. We've solved the system. We've done what B said. What I'm gonna ask on the test is, how many solutions are there? We've said there's just one. Part C says, classify the system as consistent or inconsistent. Which one? Because you need to know that for tonight's homework. That's consistent. And if there's only one solution, then do we say dependent or independent? Independent. Consistent and independent. Everything we need to know. The E part says if the system is dependent, this one's not, so I'm not worried about it yet. All right. In trying what to multiply by to cause something to eliminate, are you okay with figuring that out when we get right here?
No, I
Okay,
am not okay.
good. But I needed somebody to say that if you felt that way, because it seemed like -4, God just whispered to somebody. Yes? Okay. I was looking at what I had before I wrote in red. And I said, what would I have to multiply by 2 to make it 9? That'd be 4.5. Or what? Yes. Or what can I multiply by 1 to make it 4? It's easier to figure out what to multiply by 1 to make it 4 than it is what do you multiply by 2 to make it 9. So that's where the 4 came from, except for if I multiply by +4, I'd have a +4y and a +4y. Those wouldn't eliminate. And that's why I had to multiply by -4. All right, now just don't even write this down, but to make sure you're okay with that, Taylor, I'm gonna make up another system real quick, jot it at the top. We're not gonna solve it. I'm just gonna see if you're okay with figuring out what to multiply by. All right, I believe in you. You got it. Let's say I had 2x minus 3y equals 5 and 5x. Well, oh, I need to do another, I need to make another example like this in the notes because I just realized there's something that is not illustrated in the notes. Let's say that was my system. And all we're trying to do is figure out what to multiply by. So, Taylor, do you see something that I can multiply one equation by that would cause one of my variables to eliminate? And I can't just multiply 3y by 2, but I can multiply both sides by 2.
So you would multiply the top as well.
Yeah, anything you do to an equation, whatever you do to the left-hand side, you have to do the same thing to the right-hand side. But you're absolutely right. 2 is what you would want to multiply by. That would cause my y's to eliminate. All right. What I just realized that I did not have an example of. Ooh, maybe it happens in the word problems though. I bet it does happen in the word problems. Sometimes you have to multiply both equations by something. For example, let's say this had been 2x minus 5y equals 5 and 5x minus 3y equals 15. Let's say I had that system. I'd either have to multiply by -2.5 to cause my x's to eliminate, or I'd have to multiply by some crazy fraction to make my y's eliminate. And to not have to multiply by fractions, I could just choose to multiply both equations by something. What will 2 and 5 both go into? That's what you were saying, the least common multiple. The smallest thing 2 and 5 will both go into is 10. So make one of these become 10x and make the other one become -10x. What would you have to multiply the top equation by to make this a positive 10x? And whatever you do to the left-hand side, you have to do the same thing to the right-hand side. Now, what could I multiply by the second equation to make this become -10x? -2. And whatever you do to the left-hand side, you just have to do the same thing to the right-hand side. So often you can get by with only having to multiply one of the equations by something like we did here. But I bet my example of having to multiply both equations by something, I bet we'll encounter that when we get to these 3 word problems on the next page. All right. Now that you can figure out what to multiply by, I'm going to be quiet for a minute, which is really, really hard for me. But I think I can. I want you to figure out on 3 and 4 what you would need to multiply one of the equations by to make one of the variables eliminate. And I've set you up to not write on your original problem. Here's the original problem. Put what you're going to multiply by here, and then what you'll have after you multiply there. I want you to do that for both number 3 and number 4. And I can pre-warn you that something weird is going to happen. We got to figure out what the weirdness means. Try 3 and 4. Give me one more minute. I'm practicing with the names I'm still trying to get. I know Justin, I know Brittany Bright, I know Isaac. Miss Chloe, darn it, where are you? Oh, Chloe, I don't know why I'm struggling. I'm so sorry. What did you do to cause one of your variables to eliminate? Okay, you took the top equation and you multiplied it by 3. So I'm not gonna write on my original problem. I'm gonna say here, I'm multiplying both sides by 3, and then I'm gonna write my new system. That gives me 3x minus 3y equals 15. I'm just gonna copy down my second equation, negative 3x plus 3y equals 2. Now, Miss Taylor, what made you erase there?
Because I wasn't right.
Yeah, but if you tell me what you're thinking, then I can help you with it. What were you thinking? What did you multiply by? 6? You multiplied the bottom equation by 6. What eliminated when you did that? If you had the top equation x minus y equals 5 and this equation multiplied by 6, then you right here you would have negative 18x plus 18y equals 12. And if you added those together, nothing would eliminate. Do you kind of see that now, Taylor? Okay, and the only reason that I'm stopping, Taylor, is because you came to see me and I know you care. If I didn't know you care, I'd just roll right on whether you were frowning or not. But if you're frowning, I want to help you before we go on, right? All right, so multiplying the top equation by 3 caused me to get a new system. And holy cow, Chloe, when I add those two equations together, what did you get? You got 0 equals 17. Actually, I have 0 plus 0 equals 17, but that's still just 0 equals 17. And on what planet does 0 equal 17? Not Earth. Maybe dwarf planet Pluto, but we don't know. We're only solving equations on Earth. So what are we going to say about number of solutions here? There's no ordered pair that makes 0 equal 17. There's no solution. Now, if on the test you just stop right there and say 0 equals 17 is your answer, I'm going to say, no, it doesn't, minus 5. You got to tell me, you know what that means. That means there's no solution. And when there is no solution, what do we call the system? Inconsistent. Which has an N in it, darn it. And if it's inconsistent, then dependent, independent doesn't apply. You only use dependent, independent when there's at least one solution. All right, so we're through with that one. No solution. What about Miss Ally. Ally, so sorry. I'm gonna stop apologizing now, Ally. Tell me what you did to one of the equations in number 4 to cause one of the variables to eliminate. You just went, oh gosh, I don't know, not there yet. That's totally okay, totally okay. Yes, I still got to practice the name. And then. Hey, Maddie. Maddie, gosh darn it.
Just wanna multiply, but
Tell me what you, okay, you multiply the top equation by 3. Let's see what happens when you do. Don't add on your original equation. Multiply the top equation by 3 so that you'll get a -3. Actually, if you multiply by +3, nothing's gonna eliminate. Did you multiply by -3?
yes.
Okay, and you may have said that, I may just not have heard it. But you'd have to multiply by -3 to get something to eliminate. That top equation would become -9x plus 3y equals -21. And I don't need to do anything to the second equation, I'm just gonna bring it over. And what did you get when you added those two equations together?
0.
You got 0 equals 0. And you can't leave that for an answer either. On what planet does 0 equal 0? All the planets. And Maddie, what does that mean about number of solutions?
I said no solution,
But that's always true.
but there was
Hang on to that. That's a great thought. Tell me, that was Chloe. Yes, Chloe? I think you're right. Because this is always true. Because really, look at the two equations. The second equation is just the top equation with what done to it? What could you do to this equation to turn it into that equation? It's just the other equation multiplied by 3. And we know that when you take an equation and multiply both sides by 3, you get an equivalent equation. Those two lines are really the same line, one on top of each other. And if they're one on top of each other, how many solutions are there? Infinitely many.
consistent.
So it is consistent. And because consistent just means at least one solution, and that has infinitely many solutions. Would we say that the equations are dependent or independent? They're really the same equation. So they're dependent. Now, was it Maddie or Chloe that said, but there's no ordered pairs? That was Maddie. Okay, Maddie, there are infinitely many ordered pairs. I can't list them all. I can draw a picture of them. I can draw the one line that both of those equations would give you. Or I can do the other thing that we've been putting off, this E part. If the system is dependent, which we just got on number 4, write the solutions using set notation. I can't list all the ordered pairs. There are infinitely many of them. Let me tell you about set notation. And the only reason I'm showing you this is because the homework asked you to do this. I'm not going to ask you to do it on the test, but it's still easy. This is what set notation looks like. It's in a set of braces. Braces indicate set notation. And then you read this set notation, the set of all ordered pairs X, Y. That tells me what my set consists of. It consists of ordered pairs X, Y. that vertical line is read such that. And then MyLabs is gonna have y. You know what? It has an equals in there that I left out when I was typing. It might confuse you if you don't put that in there. So squeeze a little y equals before the box opens. That's what it looks like in the homework. In that box, I just want you to give me one of these equations solved for y. Now, you could solve either equation for y because really they're the same equation. But which one looks like it would be easiest to solve y for y? The first one or the second one? The first one, I agree. I'd take 3x minus y equals 7. I would subtract 3x from both sides. And just because I kind of like things in slope-intercept form, instead of writing 7 minus 3x, I'm going to write negative 3x plus 7. Is that the same thing as 7 minus 3x? As long as the 7 is positive and the 3 is negative, yep, that's the same thing. And then one other thing do I have to do? Multiply or divide either one, both sides by negative 1. And you get y equals positive 3x minus 7. That's what MyLab wants you to put in the box. And I'll tell you why. What we've done with this set notation is we have given the format of all of the solutions to this system. We're saying all of the ordered pairs x, y such that the y is triple the x minus 7 would be solutions to that system. All the ordered pair x, y such that y is 7 less than 3 times the x would be a solution to that system. And again, I'm only showing you this so that you can do the last thing in the homework, which asks you if the system is dependent, write it using set notation. All right. Any questions about that? Sure of it, and I want you to look closely when you're doing the homework. I don't know if it always in set notation has you solve for y, or if sometimes it has you solve for x. If it said x equals instead of y equals, just solve for x. Don't know why it would really do that. Makes more sense to get it in slope-intercept form, but just double check that. Another thing that I've had folks email me because they missed a problem was they typed another equals in the box. You don't need 2 equals. All right, any questions? If we actually get through everything in the notes today, I say we all go somewhere to like Sonic and celebrate after, but that's never happened before in this class. To try to make it happen, I wanted to show you 3 different kinds of word problems, but there was one good example in the book. I thought I could save us time if I just copy that example and then we'll do the other 2. But I want to talk to you about this first example. It says a movie theater sells tickets for $8 each, with seniors receiving a discount of $2. Now, if seniors get a discount of $2, what are they paying? They're paying $6. All right. So $8 and $6 are the prices of tickets. Not only do I know something about the price of the tickets, I know how many total tickets were sold and what the theater brought in as revenue. Revenue is what you take in before you subtract off the cost. Just they took in $3,580. The question is, how many type of each ticket were sold? Well, you're looking for two things. It makes sense to use two variables. That's why we would use two variables. We're looking for two things. So any, miny, miny, mo, let one of the things be X and let one of the things be Y. Now, what are we looking for? What are the two things we're looking for? And when you say amount, are you talking about the dollar value of each ticket? No, because you know that was given to you. Precisely what are you talking about? The number of adult tickets and the number of senior tickets. Actually, there's no children involved here. I guess this is adult theater. The number of regular tickets and the number of senior tickets is what we're looking for. And it's very important that you use the word number of tickets instead of amount of tickets, because I wasn't sure what you meant by amount. As a matter of fact, you could call that value. The number of tickets is one thing, and the value of the tickets is something else. I want to set up both equations so that the units match. We're talking about, in one of the equations, we're talking about the number of general tickets, let's call it X, and the number of senior tickets, let's call it Y, is the total number of tickets. That's the 525. The other equation isn't about the number of tickets, it's about the value of the tickets. Now, if you sell X tickets for $8 each, what's your revenue from that? X tickets for $8 each. If you sold 2 tickets for $8, what would your revenue be? 16? If you sold 5 tickets for $8, what would your revenue be? 40? So if you sell X tickets for $8, what's your revenue? 8X. That's your revenue from the general tickets. And then if you sold Y senior tickets for $6 each, your revenue is 6Y. And then that 3,580, I was told that's my total revenue. So one of these equations says number of tickets plus number of tickets equals total number of tickets. And one of them says value of tickets plus value of the tickets equals the total value of the tickets. If you're using words instead of just X's and Y's that don't mean anything to you, then you'll get that set up correctly. I think the most common mistake is when folks go X plus Y equals 3,580. Well, that's number of tickets plus number of tickets equals dollars. That doesn't make sense. It's got to be number of tickets, number of tickets, number of tickets, dollars, dollars, dollars. All right. Once we have that equation or that system set up, it looks like the easiest way to solve it. You could multiply the bottom equation by -8 if you wanted to eliminate your X's, or you could multiply the bottom equation by -6 if you want to eliminate your Y's. Eeny, meeny, miny, mo, looks like the author decided to multiply by -6 to eliminate the Y's. And they came up with X equals 215. How do you get Y once you know X is 215? Yeah, if there are 525 tickets in all and 215 of them were general, then 310 of them were senior tickets. So 215 general tickets and 310 senior tickets is your answer. The very, very important thing I wanted to show you there is how your units and your words needed to match. You say value plus value equals total value. That's all in dollars. And then number plus number equals total number. That's all in tickets, ticket sets. If you have one like that in the homework, and you have two others, I could call them both mixture problems, or I could call this one, example, the middle one, I could call it a mixture problem. And then call the last one an investment problem. But really, investment's just a kind of mixture problem. We have money from two different accounts being mixed, where in this middle example, what do we have being mixed? The store sells cashews for $5 a pound and peanuts for $1.50 a pound. The manager decides to mix 30 pounds of peanuts with some cashews and sell the mixture for $3 a pound. What's being mixed? Cashews and peanuts. Now, one thing that's very helpful to me in mixture problems is using a table to organize all my information. When I can get folks to draw this table, they almost always get the problem right. Sometimes some folks get it right without the table, but if you struggle with word problems, I would highly recommend organizing your information with a table. The two things that are being mixed are cashews, peanuts, doesn't matter which one you write first, and then some mixture of the two. That's what I'm going to label my rows, the things that are being mixed, the mixture. And then I have to figure out some good labels for my columns. What is it that I know about these cashews and peanuts? I know the price per pound, and what am I looking for? How many pounds of each that I should use? So what's important about each of these quantities is the number of pounds and the price per pound. Three pounds of peaches that cost $4 a pound. How much is that going to cost me? You just multiplied them and you got $3 a pound times 4 pounds is $12 total. If we multiply number of pounds times price per pound, that gives us the total price. So that's what I'm going to label my columns. That's the hardest part of the problem for me, just figuring out the words, because if I figure out the words, I can figure out where all the numbers go. Tell me where the 5 goes, and you got to tell me a row and a column. That's the price per pound of the cashews is 5. Tell me where the $1.50 goes. That's the price per pound of the peanuts. Is 1.5 the same thing as 1.50? Yeah, you don't have to write the 0, you can. Let's see, what's my next number? The manager decides to mix 30 pounds of peanuts. Where does that 30 go? Row and column. Is that what it's saying?
Yeah, it's peanuts.
Oh, that's just the peanuts. Oh, that's the most common mistake on the test. Read that problem carefully and see if that 30 is the pounds in the mixture or just the pounds of peanuts. And it says pounds of peanuts, so that 30 goes here. How many pounds of cashews? That sounds like the thing I'm looking for. So that sound like a good thing for X? Yeah, let that be X. And then do what your, no, there's one other number. I haven't put the $3. Where's the $3 go? That is price per pound of the mixture, just 3. Now I have all the numbers somewhere on the table. And I figured out what variable to use. I'm gonna tell you a secret here. You could let this mixed number of pounds in the mixture be Y. If you wanted to, you'd have 2 equations and 2 variables. But what would Y equal if you had X pounds of cashews and 30 pounds of peanuts? How much of the mixture would you have? Let's say I had 40 pounds of cashews and 30 pounds of peanuts. How much would be in the mixture? And how'd you get that? You add it. So if there are X pounds of cashews and 30 pounds of peanuts, how many pounds are in the mixture? X plus 30. If you don't use 2 variables, then you don't have to have 2 equations. Now we have these first 2 columns filled out. I could multiply straight across and get the total price of the cashews is 5 times X. The total cost of the peanuts is 1.5 times 30. I'm going to go ahead and tell you it's 45. And the total price of the mixture is 3 times X plus 30. And we could have let the mixture, we could let the number of pounds in the mixture be Y, but then I'd have to have 2 equations. This seems easier to me without 2 equations. My one equation is going to say price of cashews. I'm going to say total price, but just abbreviate it. Total price of cashews plus total price of peanuts equals total price of mixture. Whether you're in Miss Miles' college algebra class or Miss Sexton's anatomy class or Kroger or Walmart. Does that sentence make sense? Yeah. The cost of the cashews plus the cost of the peanuts is the cost of the mixture. And for price of cashews, we can put in 5X. And for cost of peanuts, we can put in what? 45. And for total cost, we can, or total price, we can put in the 3 times X plus 30. Just to save ourselves a jiffy, I'm going to go ahead and distribute that 3x plus 9. If you subtract 3x from both sides and subtract 45 from both sides, you get 2x equals 45. So x equals 22.5. You also need to, I mean, the answer to this problem is not x equals 22.5. Ms. Sexton doesn't know what X is, we didn't tell her. We've got to look back at the equation and go, what is that X? Or look back at my table and say, what is that X? What did X represent on my table? Pounds of cashews, so 22.5 pounds of cashews. We were only asked for the amount of cashews. We already knew the amount of peanuts. So we're through. 22.5 pounds of cashews. And to check it, if I were to multiply 5 times 22.5 and add 45, it should give me whatever that will give me. Yeah, that makes sense. I'm sorry. Because I was thinking, no, I didn't finish. I got so close. I only have one more problem to do. If you need to see this problem, hang around for 3 more minutes and we'll have it. If you can't hang around 3 more minutes, then it'll be on YouTube in just a little while. Yeah, the homework is assignment 6 and next Monday's the test. So be working on that practice test. You don't have to finish it, but you should be able to do through number. You should be able to do through number 35. We just have one more lesson for the test. All right, for my folks who are staying, let's do this investment problem. Everybody else, see you. See you. An investment problem is just a special kind of mixture problem. I'm mixing money from 2 different accounts instead of mixing cashews and peanuts. It says a recently retired couple needs $12,000 a year to supplement their Social Security. They're getting their Social Security, but it's not quite enough to live on. They need another $12,000 and they're trying to figure out how to get it. Well, they have $150,000 in savings. They're going to take that amount and split it into investing in AA bonds and CDs, bank certificates. The AA bonds pay 10% interest per year, and the CDs pay 5% per year. Now, for my poor people who haven't left yet, real quickly, why wouldn't they put all their money in the bonds if they're paying twice the interest rate as CDs? Can you? No, they got the 150,000. They're gonna split the investment, but they're gonna invest the whole 150,000. I'm just wondering why they don't put it all in the CDs, or excuse me, all in the bonds. What determines interest rate? When you're buying a house, when you're buying a car, when you're credit, because the lower credit you have, the bigger risk you are to the loaning company. If you have a very poor credit score, that's from not paying back stuff that you owe, and you're a much bigger risk to the lender, and that's why they charge you a higher interest rate. So the same thing with investing. These bonds are a riskier investment, so they pay a higher percent interest. You as long as stock market's doing well, it's going to have the higher yields. But when the stock market crashes, you could lose everything here, which you're not going to lose everything with CDs. So it's a matter of risk. All right, the 2 things that are being mixed here are what? On bonds and CDs. The 2 different accounts they can choose between. or split their money into. One other very important thing I want you to pull from the dark recesses of your brain. What's that interest formula that we've been dealing with since a long, long time ago? How do you calculate your interest on an investment? Starts I equals. In banking, the amount you borrow or the amount that you invest. It's called something, it starts with a P. Okay, I'll tell you. That's your principal. And it's principal with a P-A-L, not principal with a P-L-E. Principal is the amount you invest or the amount you borrow. And then Justin, you said that percent is actually an interest rate. And the formula that I was trying to get you to remember is interest equals principal times rate times time. Have you ever seen that before? Okay. Interest equals principal times rate times time. You multiply your principal times your interest rate times how long you keep the investment for, and that'll tell you the amount of interest that you gain on that investment. Now, the only reason we don't have a column for time here is because we're going to decide how much they need to invest in each to get that $12,000 for 1 year. They need 12,000 for every year, so I don't need a column that just has all ones in it for 1 year. When we're mixing money, we don't usually call it mixture, we usually just call it total. There's total principal is one thing, and total amount of interest is the other. And that's what the chart looks like for every one of these interest problems. All right, let's take the two easy numbers first. Where does the 10% go? That's the interest rate of the bonds, exactly right. Interest rate of the bonds is 10%, and we always change percents to decimals. Move the decimal 2 places to the left when we're going to put it in an equation. So 10% interest is 0.10. And then the 5%, that's the interest rate for the bonds. How would I write that as a decimal? 5% as a decimal.
What's your top?
Yep.
But I thought the 10% was for the bonds and not.
Did I write it in there backwards? I sure did. What the heck? And I was even saying interest rate for the bonds. I just wrote it in the wrong row. Thank you. 10% for the bonds and 5% for the CDs. All right. Now, what's the 12,000? I know it's total, but is it total principal or total amount of interest? And the other number is 150,000. One of these two numbers is the amount of interest and one's the principal. One has to be the principal. They're investing, exactly right. Their principal is 150,000. Their amount of interest is what they're wanting to earn. That's the 12,000. Miss Taylor, I'll have that on YouTube. Yeah. Take off and see ya. So here I'm looking for two things. It makes sense to use two variables. How much should be invested in each? It makes sense to use X and Y if I'm looking for two things. I'm just gonna multiply straight across. The interest from my bonds is 0.10 or just 0.1 times however much money I put in that account. The interest from CDs is 0.05 times how much money I put in that account. If I use two variables, I have to use two equations. My first equation comes from that first column. Principal in bonds plus the principal in CDs equals my total principal. That's my principal equation. And then my interest equation comes from that third column. 0.1x plus 0.05y